So what we're going to do here is look at a test style question. So first thing you should always do when you have a test question is look at all the information you actually have. So we'll read through it. We've got, when 160 Year 5 students were interested in a school placement, they were asked to sit an entrance intelligence test to assist with class levels. The scores were found to be normally distributed with a mean of 112 points and a standard deviation of 15.2 points. So the useful things here are that we have 160 total students. We know that our data is normally distributed, and we have a mean of 112 points and a standard deviation of 15.2 points. So that means that we can sort of draw a little diagram. I haven't drawn in the other points because it's going to get a little bit messy, but we know that our mean is 112. That tells us that 50% of the data is going to be lower than 112 and 50% is going to be larger than 112. So 50% of kids are scoring under that and 50 are scoring above. So the first question, what's the probability of scoring more than 120 points? In this case, we're going to use our normal CD function, which is going to be found by going to the menu. Then we're going to go statistics. And then we're going to go into dist, which is F5. We're going to click norm, which is F1, and then Ncd, which is F2. Once we're in that space, there are a few things that we're going to need to use. So we're trying to find the probability of scoring more than 120 points. That means that when we draw this as a probability, we're going to say P of X is greater than 120. So you will have seen this on some of the more simple calculation questions when there's no real context, but it is always important to write this in your answer. Now we look at the 4 points that we need to fill in. We know the standard deviation is 15.2, and we know that the mean is 112. Our lower value is going to be the lowest value that we're looking for, and our upper is going to be sort of the ceiling limit. In this case, we're looking for values of x that are above 120, so our lower value is 120. And if we remember, when we're trying to put a upper value when we want to catch all of the possible outliers, we just use a really big number, which is 1 times 10 to the power of 99. If we look at our diagram, we're going to be going somewhere around about here, I would imagine. So we're trying to find the probability or the area underneath the curve that covers this shaded section. So if we put our values into our calculator, we're going to see that we end up with 0.2993. So if we think about this, this effectively means that we've got about 29.93% of all students are scoring more than 120 points. For part B of this question, they're asking us how many of these students would you expect to score more than 120 points. What we need to do in this case is take our probability, 0.2993, and we're going to multiply that by the amount of students, which is 160. What we will find there is that we are expecting that 47.9 students are scoring above this score, and always remember to make that a whole number. So 48 students score 120 plus. When you get a question like this, please make sure you answer it with a sentence or just a brief statement. It is all good to round up in this case. Please make sure you round it to a whole number though. Question C, how many are expected to score within 10 points of the mean? So the trick here is that it's also asking you how many students, So we're basically combining what we did in part A and part B. So first of all, we need to construct some kind of probability statement here. So if they're within 10 points of the mean, our mean is 112. So we're looking for the probability that x is between 102 and 122. So we write that like so. Then we're going to fill in what we know. This one's pretty straightforward because we've actually got our upper and lower within our statement. So 102, 122. Standard deviation is still 15.2 and our mean is 112. We go back into the normal CD function and we plug in those values. We're going to see that our P, or our probability, is equal to 0.4894. Now we need to figure out how many of those students, so we're going to multiply this probability by 160. So we're going to get 160 times 0.4894, which is 78.3. So about 78 students score between, this is getting messy now, 102 and 122. So that's the kind of statement that we want to put at the end of an answer. Now we're going to move on to the next part of the question. Very similar sort of question in terms of what is written, but we're actually going to be using a different function, which is the inverse normal function. First of all, question D is actually just a bit of a, not necessarily trick question, but we actually don't need to use too much of our calculator for this. 15% of students will make it into the advanced class. How many would that be? All we need to do in this case is convert that 15% to a decimal, so 0.15, and we multiply it by however many students we have. So we've got 0.15 times 160. That means that 24 students make it to the advanced class. Now part E is where we're looking at what is that actual threshold score, or that minimum score. What we're looking for is 15% or 0.15 on our normal distribution over here, and we're trying to find the K value again. So we're going to draw a bit of a rough idea of where we think 0.15 might be. We know that pretty close to the mean, if we're one standard deviation away, it's going to start getting to that lower curve bit. Again, the diagram doesn't have to be perfect, you just have to give yourself a bit of an indication where it's going to be. That's our K. Now, if we look at our diagram, there are 4 things that we need to use the function that we're going to be using. First of all, let's navigate to that. So we've got menu, statistics, we've got dist again, which is F5. We're going to go norm, because it's a normal distribution, which is F1, and then we are going to select InvN, which is F3, and that gives us the inverse normal function. So the bits of information we need are the tail, the area, the standard deviation again, and the mean again. We know that our standard deviation is equal to 15.2. We know our mean is 112. Now the other things that we need to think about is the tail. So that is the direction that the tail is pointing in, or where our data is pushing towards, and that is going to be to the right. And then we need to put in our area. So our area is that percentage as a decimal, which we found earlier, which is going to be 0.15. If we're writing a probability statement about this, we would be saying that probability of x being greater than k is equal to 0.15. As you can potentially see, this k is the value that we're searching for, but we can't just rearrange this equation. That's why we're using this inverse normal function. So we're going to plug that into our calculator. The tail's to the right, the area is 0.15, standard deviation 15.2, and our mean is 112. That's going to give us the value of k. On your calculator, it will say XINV, and it's going to give us 127.75. So if we look at our little normal distribution here, we can see that the k is going to be bigger than 112. That's something we definitely know because there's only 50% below and above that 112, and we just want to know where our value is that sits just under the top 15%. So when we get this value of k, I'm going to have to move a little bit of stuff around. We found this k value, but we do need to answer with a sentence, and our sentence is going to be something like minimum score to be advanced is 127.75 points. Now in this case, because we've got a decimal answer and they haven't specified that it needs to be a whole number, we don't have to worry too much about rounding. If you rounded up to 128 in this case, you would not lose marks. Just make sure that you're paying attention to the context of the question.